Cool. Before adding collision, I want to increase density. So if I just check, I have lesser density over here, and currently it's loading speed, so I don't want speed over here. And I can use velocity for motion blur later, so I want to keep it invisible. So as you can see, this is a bit less and it's not clearly visible. I can use these, but that's not helping a lot. So here I have to increase simulation density. So let's just check. So if I increase this by 10 times, it will affect everything from velocity to disturbance. And let's just check, right? Now we have more coverage. That's what we want. Cool. So now let's add collision. Easiest way to add collision is using static object. So here you can just connect and it's easy. But while dealing with volume, there is a smart VDB approach is also there. And let me just show you that. So for that, we have to convert this object into VDB. So let's use VDB from polygons. Let me just hide this. And we can link this parameter with here voxel size as well. But we don't want to link that. Here decent voxel size is also fine. But if we just even increase this simulation voxel, then we don't require this kind of detailing. It's better to keep this independent, right? So we don't need that high quality voxels over here. And we will need velocity also of character, right? So it should inherit with the leg. So for that, we can just go over here and click, and here we can mention well, right? But here I don't have any option to select the areas and everything. If I want to expand it outwards, I cannot do that, right? So it's better to use separate in here as well. So I can just use rasterize attributes, and I can just connect this over here, and I can just type V. Yeah, so as you can see, it's working. And I have to reduce this particle scale, and I want to check how much coverage is it covering, and I can just select volume slice over here and check. Let me just give this template, and that's too much, right? So let me just reduce this, and I want to reduce voxel size. That's too much, so I think 0.25 will work. Cool. And here also we can just use volume trail to visualize that, this and here. Right, so here you can just visualize this, increase the radius. Cool. So for now 0.05 is fine. And if I merge, and one more tip, so if you connect this way, then always use well over here, so it's clearly read that field. Nice. And after that, 1 2, as you can see, it's taking a bit time to load, right? So I can just quickly save this character VDB version 1, save it. Let's copy this. And how do I import that over here? So here also I can just use same volume source as it's a VDB. So I'll just use volume source, and if I just check, I have option collision. So I'll just select that. It will fill up some names over here. So first is collision, and it's using -1, and after that it's using this velocity. And let's just connect this. Will this work? It won't work. Why? Because if I middle click, I have surface over here, and this is sign distance field, right? So I have to use this as a minus, and here I have to use mention. And where do I connect this? That's the most difficult question, and let me just show you why. So as it's a volume source, so definitely I'll just connect this over here, and let me increase this voxel for quick simulation. Yeah, and I want to hide velocity. I want to keep density only. Yep, let me reset. Is it properly reading the collision? We have to always cross check that once. So we can visualize the collision part as well. So I can just select this over here. I can turn on collision. And as you can see, nothing is visible in the viewport. So why is that? So collision is not meant to use over here. So it's force actually. The moment I connect this, it's visible. And this is how it looks. You can see here. Now it's reading this as a collision. Let me reset. Yep, there is some collision. And it's reading that 1.5 velocity as well. So let's just check the output. Let's make a flipbook. Let's play these. Yep, it's working as you can see here in this area. Yep, it's working, but it's too much at the moment. So maybe we can just reduce it a bit. Let's keep it one only. And I want to increase this as well. Yep, so as you can see, there is some noise we have, and that's looking good. So which noise is it? So after working with lots of parameter and lots of micro solvers, right? So it's always difficult to identify which parameter is affecting this. So in that case, just select everything. So this is the debugging that I want to teach you. So I can just select this and disable everything, and let me just reset the simulation. As you can see, this is not that disturbance. If I disable this, and let me just check, is it affecting over here? Yeah, it's affecting really minorly. Like, so first I need to get this better. Let me just disable this. Yeah, so it's affecting that, right? And here we can just one more just cross check the speed as well. So as I have already disabled the speed, so I will visualize that over here. Let me go to multi-field, and I want to read. Yep, and turn this off. So current range over here is 0.5 to 0.8. That's really less, and I want to cover more area, so I will just reduce this 0.5 and you will just skip 0.5. Yep, this is cool. 0.2 and 0.5. Yeah, just go outside. So these are the technique we need to control. You know that most of the time what we make mistake, we just keep everything turned on and we keep making these changes. So if all parameters are visible, then it's hard to find out which parameter is affecting that. Yep, cool. So let me just reset this. Nice. And now I can turn on this one. This one is wind, and this is one more disturbance. Let me just test this one. So till here it's fine. The moment I turn this on, I will have different output. Yeah, this is the force we can control. This gas disturbance is adding lots of force in it, and after increasing density we have to control this as well. So let me just type density over here, and current range is 0.4 to 0.7, 0.4 to 0.7. So maybe you can just go 3.5 and give 125. That's too less, so I think 0.6. Yeah, 0.5. Yep, that's cool. So we will use 0.5 and 1. Keep everything same. Let me just reset these. Interesting. So now this looks a bit sharp, right? So I want to break this edge as well. So let me just go ahead and turn on this disturbance. Gas fill is also fine. Collision is also fine. Let's reset this. Yeah. So this disturbance is breaking that edge. That's what I want. Nice. Yep. So everything looks cool, and I can increase voxel a little bit. Let's just check. And one more thing, we are feeding in VDB density, but Pyro solver runs over would need default volume. So we have to convert this into a VDB now. So I can use Pyro post process, select and convert VDB, combine, convert this, curl, resample. So what are these parameters doing here? So this is for like velocity optimization. So as you can see that if I middle click over here, you can see that density is 0.008 and velocity is 0.05. So here, if I middle click, and let me just use two post process without turning this on off. Okay. So if middle click, I can see here that again it's 0.01 and 0.01 only. But if I turn this on, it will just double the amount over here. It will optimize this velocity. That's what we want. So let's just use and make a flipbook. Cool, let's play this. Oops, so there is really less velocity over here. So I will have to, so I would like to increase this by 4 and let's keep this 75. Okay. So now I don't want to simulate this entire frame rate. So I'll just keep really less, somewhere around just 40 frames only. Let's play this. Yep, it's cool now. It's fixed. And I want to select render resolution also. Just press. So at the moment we are using these. So 0.005 resolution will be great for rendering. So let me just use these. Just sim version 1. And we have density, velocity, which is good thing. And we can guess it. Next, let's explore Pyro solver before rendering this.